This is the Marvin Windows 2021 Capstone project, a web application used to view machine data over a period of time. This data comes from one warehouse facility, but Marvin intends to increase the number of machines and facilities that collect data. The data being collected from these machines are in-feed wait times, cycle times, and out-feed wait times. The application uses this data to produce visual representations of the data, which will be useful and easily understood by floor workers, managers, and engineers. Our application uses the front-end frameworks of React.js and Semantic UI, Microsoft's ASP.NET for its backend, Microsoft SQL Server for its database, and Postman for API development. Our Capstone team worked on 2 web pages in order to meet Marvin's need. The navigation bar contains 4 different pages. Live Metrics is our first web page created, in which you can view the machine data for a shift. Our application will be integrated into existing projects at Marvin, so it is assumed that a machine ID will be passed to our web page for our API calls. The Live Metrics page will update every minute in order to draw new information from the database. The header will display the machine's serial number and machine name. Our first panel displays the actual units produced compared to the target for the shift. This allows for floor managers to see if a machine is lagging in order to go and fix any issues with that machine. Next is the daily unit progress panel, in which you can see what percentage of your goal a machine is at for the shift. You can also view average per hour and what the goal is for the day. Next is the cycle time panel. Due to Marvin giving us an incorrect definition of takt time, our team was unable to make a correct representation of the takt time compared to the cycle time. Finally, we have the product metrics panel. This panel is somewhat bare due to the fact that the takt time was initially defined incorrectly. What is included is the OEE, or overall equipment efficiency, and 2 of the metrics used to calculate the OEE. Availability shows the percentage of time a machine is running compared to the overall time the machine is on. The performance shows how the machine's cycle time compares to the ideal cycle time. The third metric, quality, is not shown because Marvin is unable to track this metric as of now. It is set at 90% for the sake of the calculation of the OEE. Now I'll hand it over to Megan, who will discuss the functionality of the historical data webpage.
The historical data dashboard displays machine performance metrics over a longer period of time. Users can choose to view data for a week, a month, 6 months, or even a year. They can also view the data in bar charts or as line graphs, like so. First, we calculate the OEE, or overall equipment efficiency, for each time period. On the right, the next panel breaks down that OEE metric into some useful components. Users can switch between viewing the machine's availability and the quantity it has produced, with a space left open for quality when Marvin implements that metric. On the bottom of the page, we have the average cycle time and the minimum and maximum cycle times. Cycle time is the amount of time the machine spends producing parts as opposed to idle time. All these metrics can be used by Marvin engineers and managers to evaluate machine performance over time. Perhaps one of their machines needs maintenance or even replacement, or perhaps machine performance has risen due to repairs. Either way, being able to view these machine metrics on user-friendly dashboards will assist Marvin employees in making informed decisions and improving their manufacturing process. Thank you for watching our video.